1 comma 2. Good. Very good. So these were nonlinear inequalities, not systems. A system is when we graph 2 or 3 and we shade in. Some of you forgot to shade in. You only graphed one and the other and they just leave it alone. No, you have to shade in. You haven't solved. You only graphed the equations, but you haven't solved. Okay, next topic, please. Say it again. So, okay. So you want... Okay, very good. Because you could have said, rational inequality or something, so I wasn't sure. Okay. You want the function or an inequality? Okay, very good. So let's choose a rational function. Which type? Type 1, type 2, or type 3? Type 2. Very good. Can anyone give us a type 2 function? Can anyone give us a type 2? No, no, no. The denominator is much bigger than the numerator. Much higher degree. At least one higher. That's type 3. At least one higher in the denominator. That's type 2. So if you have degree 3 and degree 2, that is type 3. If you have degree 1 and degree 5, that's type 2. So, okay. X minus 1. Let's say x squared minus 3x plus 2. Is this type 1, 2, or 3? It's type 2 because the denominator has a higher degree. Very good. Type 2. Then what? What is my first thought right away? The moment I see the function, what do I do? Factor. Very good. Because I have to find what? I have to find the domain first. Very good. So then f of x equals x minus 1. Perfect. Very good. And the denominator is? The product is positive 2, so the product is positive 2.
X minus 2 minus 1.
Very good. Good. What do I do next? I cannot. I will not touch it before I do something very important. Right. I have to write the restrictions. If I simplify and then write the restrictions, I will make a mistake from the get-go. So what are the two restrictions that I have to write? Only now I'm allowed to simplify, not before. So this is 1 over x minus 2. What happens next? What do I do next? I start what? Very good. Very good. F of x. What do I put in the chart? I have to put 0. I have to put 1. I have to put 2. And I have to put infinity. I have to write this under 1 and this under 2. What is x equals 1? Yes. What else? One more time?
Oh, no, it's a hole in the ground.
Very good. What is x equals 2? Very good. Awesome. What is the end behavior and the horizontal asymptote for type 2? Always? Forever? Okay, let's analyze this one more time. If the numerator is tiny and the denominator is big, what happens at infinities? When I divide tiny by huge, I have a cake right here. This is the cake, and I want to share it with everyone in Maryland. How much will you get when I get to you? Nothing. So, indeed, 0. Y equals 0 is the horizontal asymptote.
And then always back to right. Yeah.
We said that. Yep. Absolutely.
Did you go over again why x equals 1 of the whole? I don't remember.
Because the factor goes away.
Yeah, cancel out.
Yeah. Very good. Okay, so I need a number in here and here, and I need the sign of infinities here and here. So, please plug in 1 and tell me what is the number left and right. You cannot plug in 1 here or here because you get 0 over 0. But you can plug in 1 here. Very good, awesome. On both sides. So now I want to plug in 1.9 and 2.1 in this. And tell me the sign. Negative, I agree. And positive, I agree. So now I need to plug in 0. And it's done. What happened to the numerator? Where did the numerator go? I cannot write negative 2. Negative 1/2. Very good. Perfect, that's it. It's done. So let's try to make sense of this information. From 0, it crosses at 0, negative 1/2, right, the y-axis. And then it continues through a hole, and it goes to negative infinity. On the other side, from positive infinity, comes down to 0. Ready? When I graph a function with asymptotes, what do I have to graph first? Very good. So 1, negative 1 is a hole in the graph. Y equals 0 is an overkill because it's already there. X equals 2 is a vertical asymptote. I have to plot this point, 0, negative 1/2. I follow my chart again from approaching 0, crossing, going through this hole, and coming down to negative infinity. And on the other side, very clear. So this is the function f of x equals x minus 1 over x squared minus 3x plus 2. Very good. Next question. I will not put both a polynomial and a rational. Maybe it could be a quadratic, maybe with a word problem, and a rational or a polynomial, not both. One or the other. Good. Next topic, please.
One way below the function composition.
Function composition, very good. So let's say we have f of x equals the square root of x plus 1. I would like you to decompose it into an inner and an outer. It's an example. Give me the inner function. Let's call it h of x. And let's call the outer function g of x. What will be the inner function? Very good. And when I'm done and I get one number, which function I apply to this number? That's it. That's function decomposition for that topic.
Can you put that on?
Wouldn't that be false? That's not,
Say it again.
that same thing as followed and
So if you if you determine g comp h
Oh, okay.
of x, you will get f of x. So we're asked to decompose the function. Anything else? Anything from this test that I returned today? Is there anything that you would like to go back to? Yes, Mark?
Summation, I'll
Yes.
look
Oh, yes,
up. I screwed that up and then
that's okay.
blanked out.
That's okay. So
And we were practicing those right before the test, and I still blanked out.
that's okay. So which one am I looking at?
The number 27.
Can you read it? I don't have another.
Sure.
You had, okay, number 27. Okay, I got it. So 1 plus 3 plus 5. So 1, oops, that's no good. So 1 plus 3 plus 5 plus dot 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 plus 2n minus 1. So this is the sum from I equals 1 from 2I minus 1 till n. So when I is 1, 2 times 1 minus 1 is 1. When I is 2, 2 times 2 is 4 minus 1 is 3. When I is 3, 2 times 3 is 6 minus 1 is 5. When I is n, 2 times n minus 1. Good. Anything else from this test? Say it again.
Like I s- okay,
Can you do the,
Hold on 1 second. Yes, Tim?
no, it's okay.
Yes.
Thank you.
Sorry. He started before you said that. That's why.
Can you do number 9?
Yes.
The expand the logarithm.
Yes.
As much as possible.
Yes, number 9. Number 9. Okay, so we have log base 4. And this is the 7th root of a to the 6th, b minus 1 to the 3rd, everything divided by 16. Perfect. So first of all, I have to use only 3 properties.
I know it's the difference of whatever.
Not yet. If I have a power, I have to take the number in front. So this is log base 4 of something raised to 1 over 7, because it's the 7th root. So a to the 6th, b minus 1 to the 3rd divided by 16. That's the first rule. If there is a power, I have to take the power first. So 1 over 7. Then I have log base 4 of the top, log base 4 of a to the 6th, plus log base 4 of b minus 1 to the 3rd, and what's in the denominator is minus log base 4 of 16. Remember we said, if you'd like to remember this, and it's really simple, if a quantity comes from the top, it will have positive in front. If a quantity comes from the bottom, it will have minus in front. And now I have to simplify this because I can, and then bring 3 in front, then bring 6 in front, and then distribute 1 over 7. So remember, log base 4 of 16 is a number. And this is equivalent to 4 raised to which power is 16? Right. So all this will be replaced by 2. So 1 over 7 with 6, 6 over 7 log base 4 of a, plus I bring 3 in front, multiply by that, log base 4 of b minus 1, and then minus 2 times 1 over 7. And this is final.
Where does 6 over 7 come from?
When you took
You
the,
bring 6 in front, multiply by 1 over 7. You bring 3 in front, multiply by 1 over 7. And 2 times 1 over 7. The reason is we don't want brackets and parentheses left in this. It's not fully simplified. So that's why I distributed 1 over 7. Although if you leave it with 1 over 7 in front, I'm fine with that. But you still have to put the 6 in front and the 3 in front and change this into 2.
So you don't want,
normally we don't leave the brackets, we just distribute 1/7. But if you got to this point and you did not distribute 1/7, it's not such a big deal, I'll give full credit. Anything else from this test?
Can you go over, two
From this test?
from this test,
Okay, what does it say?
the compound interest,
Yes.
the A, B, C.
Okay. So there are two formulas. So for n is a equals p 1 plus r over n raised to n times t. Some of you put in here the interest. Some of you put in here the number of years. No, this is the number of time we compound the interest. This is the interest rate. The formulas are given. This is the number of times the interest is compounded, and this is the number of years, and this is the principal. So for continuously compound interest is a equals pe to rt. You cannot change the formula. If you are told continuous, you have to use this formula. If you are told 12 months, 12 times per year, then you have to use this. If you're told every day, then you have to use this with n being 365. If you're told by semi-annually, then you will say n is 2, and the number of years stays the same. So this is a typical type of problem from the log of chapter 4, right? Log and exponential. So please remind me, what was it? The principal was 100,000?
10,000.
Okay. Well, I stopped on time. Good. So 10,000, and the first one was asking us to determine
Semi-annually.
semi-annually. So this is 1 plus, and the interest rate was
0.04
0.04 divided by 2 semi-annually. 2 and the interest
every 3 years.
for the duration of 3 years. So this you have to plug in the calculator. No one can do this by hand. And I saw some of you added these. No, there was no need to do something like that.
So when you put it in the calculator, like for my math, you always have to do the 1 plus 0.4.
No, you don't have to. In the calculator? No. Absolutely not. And I don't recommend it either. So we have 10,000 in parentheses 1 plus 0.04 divided by 2, close the parenthesis, caret, in parentheses, 2 times 3, or just write 6, close the parenthesis, and press enter. So it's 11,261.62. So do not do piece by piece, because you may make a mistake. You may have to round up, and the answers will not come out. So what are you showing me?
It's giving me 29 plus, I don't know what
Because you put 0.4 instead of 0.04.
40% interest.
Yes, no, this is not 40% interest.
Yeah, I think my math lab has you add the stuff in the parentheses before it lets you go on.
It's a-
They shouldn't.
Wait, will you accept on the test if I just put that and then the answer?
Yes, of course, that's what I,
Oh, okay.
that's exactly what I did on the solutions. Please look at the solutions, yes. Yeah.
That's why I didn't get credit for one of these.
I'm not sure what happened. The numbers are not correct. So
It's
that's,
my fault. Trust me.
okay. Next question. Do you want to do the other ones?
No,
Or?
so basically for the quarterly, you put 4, we put 2.
Yes.
Yeah.
So 0.04 over 4, and this will become 4 times 3. And this is, if it's monthly, this is 12, and this is 12 times 3. But don't forget to put parentheses. After the caret, put parentheses unless you put in one number. If you put an operation, you have to have parentheses. So, yes, I always do that.
Could you do the continuous one? 'Cause that's
Yes.
the formula.
Very good, yes. So, yes, let's do it. Okay, so here it is. E in parentheses. So it's R raised to RT. R is 0.04 and T is 3. Please put the power in parentheses because it's an operation there. And then press enter. 11,274.9685. Now, if these numbers are not close, then you know you have a mistake
Oh, actually,
because they all have to be pretty close. Okay. Okay, anything else? Anything else from this test?
11.
Say it again.
11.
11, yes. 11, what does this say? 6, 7, 8, 9, 10, 11, yes.
Cause I got, I don't know if I just blanked out, but like I remember you could make it into 81.
I was surprised to see that because you answered all my questions when we did this.
Yeah, I don't know, my brain just.
That's okay, it happens. Everyone has test anxiety. I have test anxiety. After 100 years of taking tests, yes, I do.
100.
So, first, remember, I know I sound like a broken record, but this is the sequence of steps in my head. Okay, so first question is, what is this? Okay, it's exponential. Second question is, can I present both sides, the bases only? Can I present both bases for the same base? And the answer is yes, because 9 and 81, you can use 9. I prefer 3. Doesn't matter. You get the same answer. I get 3 squared here, and I get 3 to the 4th here.
Oh, that's what I did wrong. I was trying to make 9 into 8.
But it's okay. It's okay. If you want to use 9, you can. 9, and this is 9 squared to x minus 8. That's fine.
I had like squared values.
So but you have to write this one more time, and here you copy the base and multiply the exponents, and then equate the exponents.
I did it wrong.
Because as
I
we
made
know,
9 bigger.
when two numbers are equal, if they have the same base, their exponents have to be the same. Now, assuming you don't notice that, then you would have to apply natural log to both sides or common law. But it's way more difficult. I shouldn't say way, but it's more difficult if you don't notice that both sides can be presented. So if you don't like this, I'm fine, but normally I'm looking for prime numbers. But it works now, so that's fine. So then 9 raised to x plus 6 equals 9 to 2x minus 16. You cannot just distribute 2 to x and forget to distribute to negative 8, right? Okay. So then I have x plus 6 equals 2x minus 16. And remember, I did not cancel. I did not simplify. I did not do anything to the base. I only thought, okay, two numbers are equal, and they have the same base. If they don't have the same base, this procedure doesn't work. So two numbers are equal, and they have the same base. Therefore, their exponents have to be the same. So then I move x, because now this is linear. Move x here to x, and I get negative x. Move 6, and I get negative 22, so x equals 22. You can always go back and check, right? So here's how I check. 9 raised to 22 plus 6 minus 81 raised to 22 minus 8. Does this equal? Does this equal?
0.
0. When I plug in 2, yes. The reason why I do it like this is because it's easier. Instead of writing two quantities, I write just one line with 9 raised to the 28 minus 8 raised to 14. Is this better?
Mm-hmm.
Okay. You will have a problem like this, an exponential equation for sure. Okay. Next question, please.
This is a circle in there, does that mean the equation of a circle?
The equation of a circle, yes. Yes. Something like graph the circle, or identify the central and the radius, or complete the square to show that this is blah, blah, blah.
When it says word problems on here, oh, sorry, go ahead.
I was gonna say the formula for the circle again is x minus, what is it, c?
It's a C of h comma k, hk. So x minus h, everything squared, plus
X.
y minus k, everything squared, equals r squared. Yes. So x minus h, everything squared, plus y minus k, everything squared, equals r squared. Next question. Next topic, anything. I would redo all these 3 tests 2 days in a row, and then I'll say, okay, let me look at more equations.
What do you mean by what, this is an equation, but we don't know a lot of, so it's like, what the equation?
Yes, you may have part A, B, and C. Rational, quadratic, quadratic in form, absolute value equations, what you had on test 1.
Gotcha. Okay.
Yes, yes.
That's like word problems, any type of word problem that we had for.
On the previous test, I will stick with what we had on the previous test. However, just remember, you can still get good grades in this class, and I'm hoping that everyone passes. I don't want anyone to fail. But if you say, I'm going to do 1 problem from each, it may not happen, because you're not solidifying the skill with 1 problem from each type. So this is what I would do. I would do those 3 tests 3 times. And then I would say, okay, I need more examples of this. I need more examples of this. I need more examples of this. Okay, next topic, please.
Is it
What about-
21 on the
Yes,
worksheet?
say it again.
21 on the worksheet.
21. They were absolutely identical. There is no difference. You said 21? 21.
That's it. Yeah, I got no points on that.
The
Any
n plus 1
question?
factorial over n factorial?
Yeah.
Okay. N plus 1 factorial over n factorial. Which of these 2 is bigger? Yes. And remember, 3 factorial is 3 times 2 times 1. So it's 3. I subtract 1 and I get 2. I subtract 1 and I get 1. So therefore, n plus 1 factorial is, I know it's bigger than the bottom. So I will write it as n plus 1 not factorial, but times n factorial. So I wrote the 3, and then I stopped at 2 factorial. Why I stopped at n factorial? So from n plus 1, I subtracted 1 and I got n factorial. Because I can simplify this. So the simplified form is n plus 1.
Why wouldn't it be n plus, like?
Say it again.
Why wouldn't it be?
Cancel out.
Because you want to stop at n factorial because the
I want
denominator.
first one. N plus one.
Yes. So 5 factorial is 5. The next one I subtract 1 is 4. The next one I subtract 1 is 3. And I continue. So if I have n plus 1 factorial, that equals n plus 1. The next one is what?
Plus 1 minus 1.
Exactly, which is n. And I stop at factorial because the denominator is the same.
Okay.
So that I can simplify it. So for example, if I have 10 factorial over 7 factorial, I have 10 times 9 times 8 times 7 factorial, and I stop at 7 factorial because I can simplify these two. It's the same concept. Is this better?
I said yes.
So then the final form is 72 times 10, 710, 720. Better?
Yes.
So that's why, for example, let's look at another one. Let's say n plus 3 factorial over n plus 1 factorial. Which one of these two is the biggest? Right, so how will you rewrite? So you will not change anything in the denominator, but how will you rewrite the top then? Awesome, awesome. That's it. Why I stop here is because I can get rid of these. They are the same, they are factors, simplify them. So then the simplified form will be n squared plus 5n plus 6. N times n squared. 2n plus 3n is 5n, 3 times 2 is 6.
As soon as you go over it, I'm like, oh yeah, that makes
It makes
sense.
you feel some of the time.
Yeah, I get it.
Okay, I do accept.
It's like, where did my brain go?
That's okay, it's okay.
How about 23?
Yes, what does it say?
Evaluate the calculator, 40 external over.
Oh yeah. Okay, so with the calculator, it was what, 40 factorial?
Yeah,
Okay.
450.
So we go to 40, go to math, go to probability all the way. Not all the way, I'm sorry, probability. Use 4. So now you have 40 factorial, and we divided by what was it?
450.
450. Now you have to be very careful when you read the number, right? It's blah 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 blah, but look, there is an E and there is a 45 in there.
Oh.
This is a huge number. So it is 1.8, but times 10 to power 45.
That is like
So always when you get results like whatever they are, make sure you look all the way.
So E is always
can
10.
write-
Say it again.
E is always 10.
Yes.
So we can write.
The scientific
1.81
notation. Say it again, Tim.
So we can write 1.81
Times 10 to 45. Correct.
10 to the 45.
Correct.
Okay, you put E to down.
Well, that's in the calculator. It's times 10 to power 45. Very good.
Darn you, scientific.
Say it again.
What is that?
Right, actually something.
Yeah,
Did you do the
look at the
bar
first part.
That's scientific notation.
Say it again.
The bar graph.
The bar graph, the bar.
Yeah. So the bar graph.
Yeah, it's the same thing, you just turn even.
Okay. So we were given two functions. F of x equals 6.19 and in parentheses 1.029 raised to x, and the other function is 37.3 divided by 1 plus 6.1 e2 negative 0.052 x. So what are we doing here? What is the question asking us to do?
Choose which one.
It's closer to the.
Let's, no. We have to read the question carefully. The accompanying bar graph shows the percentage of people 25 years of age and older who were college graduates in the certain state for 7 selected years. And the years are here. 1950, 60, 70, 80, 90, 20, 2000, and 2006. Fine. The functions below model the percentage of college graduates among people ages 25 and older, f of x and x years after 1950. Question: which function is a better model for the percentage who were college graduates in 1980? So what do I need other than David? What do I need to do, no, other than Tim? What do I need to do to determine which function would be better?
Determine the value at 30 years plus, right, 1950, we go to 1980,
Yes?
right?
So what is x?
30.
30. All I have to do is evaluate f of 30 and evaluate g of 30. And the one that is closer to which number?
17.
17. I'm done. I just have to plug it in. Remember when we started the test, I said out of 23 problems, 1 is the extra credit, 9 require work, and 13 less than half a minute. That's what I said. This, maybe let's say 20 minutes, maybe. This, I don't know, I'm going to say an hour. What is that? What is 100? I meant to write 60. 60 minutes.
Plus.
Okay,
Take out one
so
plus.
9, okay, I incorporated it. So 9 60 minutes, and 13 should be 1 minute each. So, but now the difficulty here, because all problems are different. What is the difficulty here? If you don't put parentheses around the top and parentheses around the bottom and parentheses around the power, you are not going to get it. So you have to be very careful. So let's do that. So the top doesn't really need parentheses, but you know me, I love parentheses. 37.3, close the parenthesis, divided by, in parentheses, 1 plus 6.1 times E. Parentheses, do not forget parentheses. Negative 0.052 multiplied by 30. Close the parenthesis for the top and close the parenthesis for the denominator. And press enter. And we get 16. And this is the closest to 17. But let's do the other one. It's 6.19. And in parentheses, 1.29, 1.029. And caret. Although this is just one number, please get used to putting parentheses for powers. So this number is 14. So obviously between these two, for 1980, I cannot extrapolate to the other years. But for 1980, the first one, which was G, is better because it approximates 17 closer than this one, 14.5 or 6. Is this okay?
Oh, yeah, you got 30.
Because that's the scale of the chart.
Yeah, so you're looking for 1980, and you're going from years after 1950. There's 30 years between 50 and 80.
So it's either 1980 minus 1950 or 1930, which is your scale.
Is that okay? Say it again, Antoine. Oh, is it a yes or no?
Yeah, that's fine.
Okay, next topic. Is there anything else?
GU14, just, you don't put all
Yes.
of them.
Yes, what is 14?
The academic level.
Logistic work function.
Yes, let's do that. So in y equals, clear, and I would put in 110,000. This is one of those problems with 30 seconds, really.
14.
So they have a different 14 maybe.
They have, it's the same problem, but
Which
it's
14?
a different number. You'll see. So it's the function, the
It's number
logistic.
4 for us.
Yeah, because I crossed out the problems.
Yeah, I got them.
Okay. And E, don't forget parentheses, negative x, close the parenthesis, and close the parenthesis for the denominator.
Okay.
So now we want to plug in, what do we want to plug in? I just closed it. What was it? We want to plug in initial, so second and table, 0. And then we want to plug in 4th week. You remember this problem? We did it in class, right? You do? Okay. And then what is the limiting size? I don't know. Although it's easy to see, but I don't want you to memorize anything. Okay, I'm going to say as time goes by, okay, let's say 40 weeks. Oh, 110,000. Let's say 50 weeks. Oh, 110,000. Let's say 400 weeks. 110,000. So that's the limiting size of the population. As time goes by, if there are 110,000 people in
The top number is typically the
16.
max total population.
if there are 110,000